tomorrow will be better. Two balls, 2 kilograms and 8 kilograms, are released simultaneously from the same height. Which ball falls first? Many of you have been battling with this kind of questions. Some of you, because you've heard the answer so many times, you've grown up to believe that the two balls will fall at the same time. But you don't know why it's so. Others will say, oh, of course, the heavier mass will fall before. But let's bring clarity to this doubt. Solution. Now, the quantity, the physical quantity which is at stake here is the time of fall. In other words, the question is asking us which of these two balls will have a shorter fall time, all right? So let us look for the formula which addresses the fall time of an object and evaluate for both objects, okay? So now it's free fall. That's another thing I want to lay emphasis on. We're talking in the context of free fall. And in the context of free fall, no other forces are in action but for the force of gravity, or but for the acceleration due to gravity, all right? So now, from the very first equation of uniformly accelerated motion, which says v equals u plus at, we will have here that u is 0 for both masses because they are released, okay? Release means that there was no initial velocity. So from here, it implies that the fall time is going to be equal to v all over the acceleration due to gravity, which in this case is g. Now, for ball 1, mass 1, which is 2 kilograms, and then mass 2, which is 8 kilograms. We notice clearly here that for mass 1, we will have T1 equals to V1 all over G. And then for mass 2, we will have T2, which is equal to V2 all over G. Notice here that both of them have the same acceleration due to gravity. And in both equations, mass doesn't figure out anywhere. In conclusion, the mass of an object doesn't affect its fall time as long as we are in the context of free fall. And there's an important assumption here to make difference, is the fact that there are no resistive forces. There's no air resistance. For this reason, the time of fall doesn't depend on the mass of the object. Both masses will fall at the same time because tomorrow will be better.